So finally, let's summarize what we learned in the last two videos, which is about redox reactions and its application for batteries and galvanic cells. First of all, the first paragraph down here says what a galvanic cell actually is. Galvanic cells are two separate half cells for the reduction and oxidation reactions. What this does is it ensures that electrons move through an external wire and produce electricity. If we don't have the separation of these two reactions, we just produce heat. The second paragraph here talks about the terminology and how you go about explaining or describing a galvanic cell. What we have is electrodes, and these guys are given names. Oxidation occurs at what we call the anode, and that is negative in a galvanic cell. This is where electrons are lost. Oxidation occurs at the anode where electrons are lost. These move towards the cathode, which is positive. This is where they're gained by the reduction reaction. So the second paragraph here summarizes what's actually happening chemistry-wise in a galvanic cell. Our last paragraph talks about the last section of our galvanic cell, which is our salt bridge, or what's sometimes referred to as an electrolyte. The reason we have our salt bridge is the fact that this is there to complete the circuit and also to make sure that each of the half cells remain neutral. As electrons are moving towards the cathode, what we need to do is make sure they're balanced out that charge with a positive cation. So this is a summary of everything you need to be aware of for galvanic cells and batteries.